Welcome back to the Caribou Data Science channel. It's the afternoon of Friday, November 20th, and I'm just getting ready to update my database for today. This is a subtle reminder as a subtle reminder, I collect data from three different sources: the European Center for Disease Prevention and Control, Johns Hopkins University, and the New York Times. So let's go out here and let's just download the European data set. Okay, let's just open up this then. Open up this. It never hurts to do some data cleaning before you import the data, and that way it can reduce the size of the data you're actually importing. Let's do this. Paste. Not really sure why I do that for, but anyway, let's go ahead and sort this. There we go. Save this as a CSV file to our data directory. Okay. Okay. Let's get rid of this now. Open up our command prompt. Let's see. Excuse me. This is, of course, just the Johns Hopkins data. We have a wealth of different types of COVID-19 data available under GitHub repository. Let's see, COVID-19. Pull that data. Okay, let's go back over here then. Johns Hopkins data. It's worth noting that these numbers, Johns Hopkins data, is actually uh, Johns Hopkins data is actually cumulative total. So that means the number for today is the total number of cases and deaths from day one up until today. Okay. While the European Center for Disease Prevention and Control's data set is is a daily number. By the way, if you click on the description, you also see I have a link to buy me a cup of coffee. We can click on that link, and donate money, help buy me a cup of coffee for today. I also want to thanks to my 49 subscribers. I really appreciate all you guys and girls out there, but also ask one simple request. That is when you watch the video, click a like and a share, and also don't forget to click the bell next to the S in order to keep up to date on all the latest videos posted to Caribou Data Science channel. Okay, so this takes care of all of our data. Okay, let's open up. So let's go here. Let's go to our database. Let's go to our database setup. So we'll run this here. Okay, okay. Now we're going to update the final data set. Okay, we'll go see this to the 19th and this to the 19th. Now we'll be able to compare. Now we'll update the two John Hopkins data tables. We'll create a John Hopkins daily table for cases and a John Hopkins daily table for deaths also. Okay, let's go ahead and run this one right here. Then you will see there is a little bit of difference between European Center for Disease Prevention Control's numbers, New York Times numbers, and the and and the New York Times and the John Hopkins and the European Center for Disease Prevention and Control. Okay, this is a U.S. COVID-19 source data comparison. You can see here that European data set says 38,419 on average. This says 38,948. This says 30,792. So none of the two agree with each other. Well, they both say 300 now, 38,000 now per day. Cases, deaths, 945, 946, 948, 952. So these numbers are creeping up a little bit. I think at one point they were as low as 930. This is significant enough to actually cause to offer numbers or predictions. Nothing really surprising here. This is the Europeans uh, plot of the European data for the U.S. Plot of the John Hopkins number. Now, to me, this looks a little bit steeper here. Okay, that's a little steeper. Now we got this one here. Clearly, this is a huge, massive spike. We're way up here now for New York cases. Now, if we take a look here, you can see for the most part, they really agree. The numbers actually agree pretty well on cases. Let's take a look at deaths now. The question is it possible this is actually more accurate? Okay, that's the question. We would assume this is wrong, but is it possible that this is more accurate? As you can see, deaths are beginning to climb again. They're above this number here now, and they're to this line here. Okay, which was put at about 1,500 deaths, average deaths per day. Once again, see what's going on here and here. Now, interesting enough, These two here have a lot more volatility in the European data set, which is really kind of strange. Okay. But look at this. This is the problem right here, of course, right? These numbers up here. Everything else pretty much agrees. But look at these spikes here. 3 days. April 16th, April 18th, and then April 24th. And we can also see a little bit of spike over here. Okay. Again, this is European data sets numbers. Down here briefly, a little spike right there. The question, is this enough to raise a question about the quality of the data? Hmm, could be, and of course that's why I'm running Benford's law, which is which is one of the techniques used by forensic analysis to identify fraud, particularly in financial business and financial gain, particularly in financial aspects of business. Lots of videos. The basic concept is actually very simple. The actual R code to do it, even the Excel code to do it, is actually very simple. Okay, that's the thing I want to point out. If it's an incredibly simple line of code to actually be so powerful, it's kind of interesting. Okay, a moving average. Again, exponential moving average. The average number. This is cases. Okay, so it would appear that the data set. Let's just do a more quick peek here, shall we? Just a quick visual inspection. 119. Good. That isn't going to change. Let's just do something here. Let's start this. 1120 deaths, 2018 deaths. That's definitely a spike up. Yowza. But here's the thing: it's up, it's down, it's up, it's up, it's up, it's up. 4 straight days of incline. Okay. You can certainly see a massive spike up here. This will certainly be above the average as well as this. But okay, if we there's two above average. They're two above the number we need to have for to reach that magic number of 430,000. I think it is. Okay. Okay, so the data looks good. Let's come back over here now. Last thing we want to do is upload the database to the upload the database to GitHub. Okay. So let's come back over here to this. Okay. Let's commit these changes. Okay. So that takes care of the database update for today. I'll catch you in a couple minutes for the reports.